Hello again. So this is our new series in circuit analysis to observe some tips and tricks which a newbie can counter while solving some circuit related problems. Okay, so in this series we are going to discuss each and every situation which might be very difficult for the newcomers and might hinder their progress in circuit solutions and circuit solving capabilities. Okay, so the first question here is the first tip related is with the open circuit. Okay, so in solving some questions like here, let me have a question in which we have a source here. Okay, that is the circuit and a simple resistor here. Similarly, this is a resistor, let me call it, this is a 5 ohm resistor and the voltage source here is of 10 volts DC. Okay, so suppose this is V of S, this is VR, and I want to find out the voltage here. So what will be the voltage here? So many students find it difficult to calculate the value of the voltage here. So just remember that in order to find the value of voltages in any circuit, what you have to do, you just have to use a rule which is called Kirchhoff's voltage law. Okay, so in solving the circuit like this one, what will happen, you have to write the value of V naught, and the value of V naught can be calculated by here Vs minus Vr. Okay, this is the total voltage and the voltage which is consumed across the difference between that voltage and the source voltage will give me the V naught. Okay, so let me see here again that what is the value of V naught. The value of V naught, Vs, is 10 volts. What is the value of Vr? The value of Vr is the current flowing through this resistance and the value of resistance. Okay, so by calculating the values by using this formula, we can easily find out the value of the voltage across this one. So let us see that what will be the voltage or what will be the current here in this circuit. Okay, as we can see here that there is an open circuit here, we can easily see that this circuit here is basically the open circuit. Okay, so in any open circuit, we can easily see that in any open circuit the value of current is always zero. Okay, so when the value of current here is zero, the value of current across this one will also be zero. Okay, the current IR will also be zero, as there is no current flowing through this circuit. Therefore this formula will give me V naught equal to 10 minus 0 multiplied by R, which will ultimately give me the value of 10 volts. Okay, so that is a very common problem with the new buyers, that they cannot calculate the value which is across the open circuit. Any open circuit, the value of voltage is known, some finite value of the voltage is here, but the value of current is zero, always zero. Okay, so that is the trick and tip number one. I will come back with another tips and tricks very soon. Thank you so much. Hello again. So now let us discuss the tip number two, in which we have to find out the value across the same open circuit voltage, but the circuit here is now like this one. Okay, so that is the circuit here. Okay, so this is some known resistance here, let me call it again 5 ohm. This is again 5 ohm, and the voltage here is, let me call is 20 volts. Okay, and what is to find here, we have to find the value of V naught here. Again we can see very clearly here that this circuit is also the open circuit. Okay, so we can we use the previous rule which we have developed ourselves? No. Why not? Because this open circuit voltage is across this one, which is, let me call it V5. So the value of V5 is equal to V naught, and this V naught can be easily find out by using the voltage divider rule and the sum of the resistors in this series circuit, because this and this are now in series, because when the current will enter this junction, it will not pass through this one because the value here cannot be found out because it is an open circuit. Okay, and across any open circuit we have the value of current 0, so all the current will flow through it, and this will give me a circuit like, okay, so that would be the circuit. This is a 5 ohm, this is 5 ohm, and this is Vs equal to 20 volts. So we are going to find out the voltage here, and this is basically V0. This is the same scenario which is here. So 5 divided by 5 plus 5 multiplied by how much? Multiplied by the source voltage, which is 20. So 5 divided by 10 multiplied by 20, and this will give me the answer of this circuit here. Okay, so that is tip number 2, in which we don't have to be confused with the circuit like this one, and we have to see the loops where the voltage is being developed and the current which is not flowing through the other branches here. Okay, thank you so much, and I'll see you soon. Welcome back. So this is tip number 3 in circuit analysis, and in this tip we are going to discuss a very simple circuit in which we have two resistors which are connected across a voltage source here. Okay, so this is, let me call it V of S, this is R1, this is R2. Okay, so let me call this is V2, and I have to find the value of V2, which is VR2, such like that the value of R1 and R2 are similar. So now in order to find the value of VR2, we have to find the current here, and then after finding the current we have to find out the voltage here, because V2 is equal to I2 R2, and it will become very messy if we have more than 2 resistors here. So just remember that if we have the same resistors which are connected in series, so in finding the value of voltage across the resistor, that resistor, if the value of resistor are same, will be equal to the Vs divided by N, where N is equal to the number of resistors which are same and connected in series. Okay, so let me have here the Vs equal to 100 volts, and the value of R1 here, let me call it 20 ohm, and the value of R2 is again 20. As the two resistors are here of same, so the value here V20 will be equal to 100 divided by 2. What is 100? 100 is basically, let me change the color here. What will be the 100? So 100 is the source voltage here, which is also here, and N is the number of resistors which are connected here. So the number of resistors here are 2, so that's why we have written here 2. So value of V2 will be equal to 50 ohm. Okay, similarly if we have here, it is not 20, if we have here 30 or 300, let me call it 300. Okay, if the values here are 300, let me remove it and write it clearly here. R1 is 300 ohm, R2 is also 300 ohm. So what will be the V300? Okay, so the V300 will be equal to, as the source voltage is same here, so it will be the same, and the same number of resistors are connected here, so the value which is developed across 300 ohm will remain same. Okay, similarly if it is 1000, and if it is 1000 and the R2 is also 1000, so the voltage developed will remain the same, and if it is 1, the other voltage will also remain the same. In order to prove it, how to prove it, let me have R1 equal to, so R1 divided by R1 plus R2 multiplied by Vs, and this is due to the voltage divider law. Okay, so it will happen here? So if R1 is equal to R2 equal to R, so what will happen here? VR1 will be equal to R divided by R plus R multiplied by Vs, or R divided by 2R multiplied by Vs. Okay, let me move down here. These two R will cancel out, and at the end what will happen? Value of VR will be equal to 1 by 2 Vs. Okay, so that is the solution of this example. Similarly, if we have the number of resistors which are more than 2, so how to find the voltage here, and the resistors here are of equal value. So if here R1, R2, R3, R4, and here this is the V of S, so what will be the value of this V3? Okay, so as we have, as the values of R1 is equal to the R2 is equal to R3 is equal to R4, so the value of Vs will be, sorry, the value of V3 will be equal to the Vs divided by the number of total resistors which are same, so this is 4. Okay, so the same voltage will be developed across each one of them. And similarly, if we have the n number of resistors which are similar, so V of n will be equal to Vs divided by n. Okay, such that the value of R1 is equal to the R2 is equal to R3 up to Rn, which are all equal in values. Okay, so this is one of the very important rule which has to be followed in all the circuits, and in many exam questions, MCQ questions, and many interview questions, this rule will make your life easier. Okay, thank you so much, and I will see you with other tips and tricks very soon. Thank you so much, and I'll see you soon. Hi again. So today we are going to discuss the tip number 4 in electric circuit analysis problem. So this tip is basically related to the short circuits. Okay, so the benefits of using the short circuits and all the analysis problems which are related to this short circuit problem will be discussed here. So suppose we have a circuit like this one, in which we have a source here. It can be the current source or voltage source, but let me consider it a voltage source here, and there is a resistor R1 here. Similarly, the connected resistors here are this one. Okay, these are all the resistors which are connected with my circuit here. Okay, so let me call it R2, R3, R4, R5, and R6. So let's say this is our circuit. So when the circuit is shorted from this end to this end, what will happen? Okay, what will happen is that the circuit will just remain like this one. This circuit will just remain here, and what will be the equivalent circuit now? The equivalent circuit will be now composed of just one resistor, and that resistor would be this R1. Why this? The question is, why is this happening? It is just because that whenever we short circuit two terminal of any circuit, then what happens is when a current will try to come here and it will try to divide through any junction here, it will try to follow the path in which it finds a very low resistance here. Okay, so as the resistance of a short circuit is 0 in ideal cases, and therefore the current will always pass through this short circuit, and therefore the voltage through it will always be 0. Okay, so that would be the case, and here we can find it that when we short circuit any element here, all the current will flow through this one. Okay, so that is the circuit here. Similarly, now there is another scenario here, that if we have a short circuit, okay, let me have a short circuit in another place here. Okay, so let me have a short circuit here. Okay, so what will be the equivalent circuit here? Now let me, this is R3, this is the R4. Okay, so what will be the equivalent circuit now here? So in order to draw the equivalent circuit here, let me use the green color here. So whenever a current will come here, now it will have two paths, this one and this one, and it is not going through the short circuit now, and this short circuit is also away from here, so it will not follow through this one. But whenever this current will reach this junction, what will happen? Now it has two paths here, and the one path here has the lowest resistance possible, which is R equal to 0. So all the current will flow through this one. Okay, so now what will be the circuit here? What will be the equivalent circuit here? The equivalent circuit here will be like this one. This will remain the same, this resistor will remain the same because the same amount of current is flowing here. But as we can see here that after this junction, only all the current will flow this through this one. Therefore this circuit will remain this one, R1, R2, and here R3. So it will be the equivalent circuit here. So what is the conclusion here? So the conclusion is, if a short circuit is placed across any parallel element with this one, it will replace that resistor, and therefore that resistor will be neglected and all the current will flow through the short circuit here. So that is the answer here, and that is the tip number 4. Thank you so much, and I will see you soon. Hi again. So let us have another type of circuit here, and in this circuit we have some resistors which are connected in a manner like here. This is a bridge circuit here, here. Okay, so we can easily see that this is the resistor R1, this is, let's say, voltage Vs, this is R2, R3, R4, and R5. Okay, so we can easily see here that the equivalent resistance will be the R2 plus R4, which are basically these two resistors, which are in parallel with the R3 plus R5. Okay, after finding it out, let me have a R, the Rx, and it will be added with the R1, and that will be my equivalent resistance. Okay, so that is the major takeaway from this circuit. But let me have a circuit like this one, that I have shorted these two terminals. So what will be the equivalent resistance here? Okay, so now you can see here that now we have two circuits here which are two in delta configuration here. Okay, the upper delta and the lower delta here, and these two circuits can be represented like here and here, and then at the end these can also be represented like this one, and at the end when these resistors will be represented like here, so it will be like this one, with which other two resistors will be here, and the finding the equivalent resistance will be easier here. But here we have another scenario. What is the configuration here? This is basically not the delta connection here. Why? Because the two ends of R2 and R3 are connected with each other, and according to the definition of the parallel circuits, if the two ends of any two resistors are connected together, these two resistors are in parallel with each other, just like here. So what is the equivalent configuration here? So let me write the equivalent configuration here. So let me have here R1, and after R1 I have here this one. Let me have here the R2 and R3. Okay, so these two are shorted together, R2 R3. Similarly, these two ends of R4 and R5 are also shorted together, so this is R4 R5. Okay, so let me simplify them more. Okay, when I will simplify them, let me move down. When I will simplify this circuit, what will happen? So this simplified circuit can also be written like this as well. Okay, so this is the more simplified version, where this is R1, this is R2, R3, R4 and R5. Okay, so you can very easily see here that these two are basically equal configurations, in which R2, R3 are in parallel, where R4 and this is R5, these two are in parallel as well. So after finding when these two after finding the parallel combination of R2 and R3, the two configurations will be in series with each other. Okay, so now we can very clearly see that if this is Rx and this is Ry, so the equivalent resistance here will be what? R1 plus Rx plus Ry. So that would be the equivalent resistance here, and we can easily use all the other methods here, that if the total current here is passing through here, so after this total current, what will happen? By using the current divider law, we can very easily find the values of current I2 and I3. Similarly, these two will combine here again. Let me use the black color here. Okay, so let me use a black color here. These two will combine here again, and at the end again these two will be here, where it will be I4 and it will be I5. So by using the current divider law, we can easily find out the values of I2, I3, I4 and I5, where the value of the total current will be equal to the Vs divided by R equivalent. So in this way you can easily solve the problem which seems very difficult to you. Okay, so that is the trick number 5, and I will see you with some more tricks and tips. Thank you so much. Hello students, so this is another tip, which is the tip number 6, related to the electric circuit analysis. So again, let us have a circuit in which we have a configuration like here, and this is again a bridge circuit here. Okay, and which is connected with this voltage source. So here the value again of this resistor R1, R2, R3, R4 and R5. And what are we asked to find? We are asked to find the value of this V0. Okay, we are asked to find the value of this V0. So how to find it? Very easily. So let me sketch this circuit once again. So when I will sketch it again, what will happen here? This is the circuit. Okay, so this is basically the same circuit with which a voltage source of Vs is connected. This is R1, R2, R3, R4 and R5, and we are asked to find the value of voltage V0 here. Okay, so that is V0 here. So what will be the voltage here? We can easily see here the voltage across these 2 points will be same, and let me call it V prime. So what will be the value of V prime here? Let me call this V prime, and after finding the value of VR1, we can easily see here that the value of V prime will be equal to the original value minus the value which is consumed across this R1. So the value of this is here. Okay, so that is the V prime here. We can easily see here that this is the value. Okay, so similarly, what will be the value here? Let me use the blue color here. So what will be the value here? So let me call it V2, and let me call it V2 prime. And what will be the value here? Let me call it V3 prime. So when this voltage will be here, the current will move towards this one, and the voltage which is consumed across the 2 ohm, this R2 will be V2. Okay, so what will be the value of V2 prime? The V2 prime will be equal to the V prime minus V2. V prime is this voltage minus the value of this V2 which is consumed across this one. Okay, similarly, what will be the value of this V3 prime? The value of V3 prime is this V prime minus the value which is consumed across this R3 resistor. So that would be V3. Okay, so these are two voltage values here. So what will be the value of V0 here? We can easily see here that the value of V0 here is this V2 prime minus V3 prime. So putting these values here, what will happen? This will become V2 minus V prime minus V2 minus V prime minus V3. Okay, so what will happen? It will become V prime V2 minus V prime plus V3. So these two will cancel out, and at the end I will get the value which is V3 minus V2. So that is the value of V0. So what is the takeaway from this video? So the takeaway here that if you know this voltage and if you know this voltage, which is basically the V2, and that is I2 R2, and similarly if you know the V3 which is I3 R3, so you can easily find out the value of V0. That would be V3 minus V2, and here it is. Similarly, if the polarities are reversed, just like plus is here and minus is here, what will happen? So then V0 will be equal to the V2 minus V3 in the scenario when the polarities are reversed. Okay, so that is the tip number 6, and I will see you with some more tips. Thank you so much, and see you soon. Hello students, welcome back. In the last lecture we tried to discuss about the potential differences or the polarities across different elements of a circuit. Now in this lecture we will try to differentiate between the point voltages and potential differences across many elements in a circuit. So before going into the details of our circuit, let us have a scenario. So suppose you have to go through 3 shops. This is shop number 1. Okay, this is shop number 2. This is shop number 1. This is shop number 2, and let's say this is shop number 3. Okay, so you have to go through these 3 shops. This is 1, this is 2, this is 3, and the rule here is that whatever rupees or whatever you have to consume all the bags here, so that when leaving from the last shop you would have no bucks or no money. So suppose you have here $100. Okay, so suppose you have $100. You now enters the first shop, and here you consume almost 20 bucks, $20 here. Okay, by leaving the shop, now you have here, let me use this color here or change it. uh, yes, okay. So by leaving this, now you have only $80 in your pocket. Okay, after it you enter this shop, and here you consume, let's say, $30. Okay, when you consume $30 after leaving the shop, how much money would you have? You would have 30 out of these 50, you will have now $50. Okay, after it you enters this shop, here you have to consume the overall money, because the rule is when coming out of the last shop you should have nothing in your pocket. So you will consume $50 here, and when you will reach this point you will have nothing in your pocket, and this is the overall scenario. So you can see here that this shop was a little bit expensive, this was also expensive, but this was not that much expensive. This is the overall scenario in which you have some money, you enter some place and consume that money into those places. Okay, so this was the shop example. Suppose similarly you have a circuit which is composed of three resistors, this one, this one, and this one. Okay, these have some resistances. This is R1, this is R2, and this is R3. The resistor it has is, let's say, this is 10 ohm, this is 15 ohm, and let's say this is 50 ohm. Okay, when you connect a voltage source here, plus minus, and the value of this voltage source is, let's say, 100 volts. Okay, let us give this it the same value here. So when you will use it and use this voltage source, and you will have to find out the voltage drops here, and someone asks you what will be the voltage drops here, you will say that it will be, let us say, okay, let us remove the values here. Let me remove the values here and use it like an hypothetical circuit. So the voltage drops here will be, concept is like the same. This is 24 volts here, the here 30 volts, and here we have 50 volts. Okay, what will be the polarity which we have discussed in our last section, which was plus minus when we consider clockwise current direction. This will be like this one, and this one. These are the voltage which are dropped here, and it is similar like this shop and money problem. Okay, so these are all the scenario. Now the problem is how to find out, if someone asks you what will be the voltage here at point A, what will be the voltage here at point B, what will be at C, and what will be at D. How would you find it out? Okay, it is basically the same problem. Whatever we have solved here will also be applied here. This is the 100 voltage, 100 will be here, 100 volts will be here, because nothing has been consumed. Now the current has entered through this resistor, it will consume 20 volts, and at the end what will be left here, the value which was here, which was the total value while entering, minus the consumed value. So what was that value? 100 minus 20, so it is 80 volts. Now here we have 80 volts. At point B we have 80 volts. Similarly, when this 80 volt is here, it has come here, the current has passed through this resistor, Now 30 volts are consumed. What will be the value at V of at C point? That would be again now 80 minus 30, the value of money which a person was entering a shop minus the value which was consumed was equal to $50. Similarly, here we have 50 volts. Similarly, when it enters through this one and leave it, the value here at D will be equal to 50 minus 50 volts which was consumed, and it is 0. It is we have made this rule. Similarly, the same rule has been applied here by KVL. KVL says that all the voltage which a source has will be consumed across all the circuit elements available in a circuit, and at the end we will have them equal. I mean Vs minus Vr1 plus Vr2 plus Vr3 up to Vrn will be equal to 0. So that's why I have told you this rule here, and I have shown you that from the last resistor, the all the voltage which was at its one end will be consumed, so that it will obey this equation number A. So this was the basic concept in finding the point voltages and potential differences at all the points A, B and C. These are the point voltages, while at the other points which are these are called potential differences, because we can see here that VR1 is equal to VA minus VB. Similarly, VR2 is equal to VB minus V of C, and VR3 is equal to VC minus VD. By putting values here, we can see it very clearly that we can very easily find out the value which is consumed when a person was entering a shop and leaving it. This was the potential difference. Similarly here, 80 volts minus what was the voltage at C, this was 50, so the consumed voltage was 30 volts. And similarly here, 50 volts minus 50 volts, sorry, the 50 volts minus 0 which was at point D, so it was basically 50 volts which was consumed. So all of these are basically the potential differences or the voltages which were consumed by different resistors. So I hope the concept is clear now. Hello students, welcome back. So in this lecture we will go towards the for finding the polarity across different passive elements. So in other lectures we have solved some questions related to the current or voltage drop across many circuit elements. Now we will dive into the details of the polarity of different circuit elements, because it is the main hurdle for many students in finding the correct value of current and voltages, and they cannot even note the correct value of polarity to any passive element. So to find out the value of the polarity of different circuit elements, let us have a very simple circuit in which we have a simple resistor and the voltage source. The value of the resistor is, let's say, R, and R is 1 ohm. Similarly, the voltage source is V of S, and it is, let's say, 10 volts. So in order to find the value of current here, we can see that the value of current is, let's say, I of R. So in order to find the value of current here, we can first of all consider the direction of the current. So let us choose the color of our current. So this is I of R, and here we have chosen its direction is clockwise. Okay, this is the direction and for it I will try to solve it. So here, in order to find out the value of current, we have a very known law which is called Kirchhoff's voltage law, which states that in any loop the sum of the all voltage rises is equal to the sum of all voltage drops. Now the basic question is, what is meant by the voltage drop and what is meant by the voltage rise? So using our demonstration here, and to find out the value of voltage rise and what is meant by the voltage rise and voltage drop, so let us have a table here. Let me draw a table here. This is a very simple table. Let us have it here, and okay, so this is the table. Let me call rise, and this is the voltage drop. So the terminal where the current enters and current leaves. Okay, so when in the element the current is entering through the negative and leaving the element through positive, this is called, let us have another column here, and this is in, let's say this, sorry, let me make it again because it is not looking that much good. So okay, so this is called the voltage rise here. Voltage always rises for the power sources or voltage sources, current sources. For these are the voltage rising devices. Similarly, the elements where the current enters at the positive terminal and leaves at negative terminal, so this is called voltage drop, and it occurs for all the passive or active elements. Both the elements are included. Okay, let me rebuild it again. Okay, so not only the sources which are the active elements uh, across which it occurs. So the voltage rise occurs always for the active elements, while it drops across passive or sometimes across active elements. So in this is basically the table which shows us the concept of voltage rise and voltage drop, and for it we should always have the polarity across all our elements. So this is the overall concept. This table is very important and it will be very handy for our upcoming lectures. So it was the basic concepts, and please try to grasp all the concepts which are mentioned here. This is basically the table which shows us the concept of voltage rise and voltage drop, and for it we should always have the polarity across all our elements. When it comes to the voltage sources, the polarity is already defined because all the DC voltage sources have negative terminal, positive terminal. But what about the passive elements? Just like here, the resistor doesn't have the predefined polarity. So in finding out the current value of current or value of the voltage across it, we have to give it the polarity which is according to the rules defined here, and these are the theoretical rules. So when we can see here that for this circuit here, the current is entering through the negative elements and it is leaving the positive elements. So here the voltage is the, this voltage is the voltage rise, which is V of S. Similarly, for the passive elements, we have seen here that for across the passive elements, we always have the voltage drop, and for the voltage drop, we developed a rule in which the current always enters through positive and leaves through the negative. So therefore, it is the, for our defined direction of the current is entering through this terminal and leaving through this one. This is the passive element, so that's why the polarity here is positive and negative, and this is again the voltage drop, and it is denoted by V of R. Okay, so I think it is clear now that how to define the polarities of the passive elements, because for the active elements it is already defined, and here in this scenario the voltage across the active element is rising voltage. So putting our values here, this is V of S, and V of S, the value of V of R is I of R into R, or we have to find out the value of I of R, and I of R is V of S divided by R. Value of putting the values here, this is 10 volts, this is 1 ohm, so this is Ohm's law. According to Ohm's law, the value of current is 10 amps. Okay, so this is the value which we have calculated for our clockwise direction. Similarly, let us consider another scenario. Let me remove all these. Okay, this is the resistor. Okay, let us consider again another direction of the current, and this direction is basically the counterclockwise, and let me write it here. This is scenario number 1. Scenario number 2, the value is counterclockwise direction. Okay, wrong direction. This is the counterclockwise direction. So again, now here we can see the values here. Again, this is the passive element, and I have told you by changing the direction of the current, the polarity of this theoretical polarity of our resistor will also change, because for our resistor is the passive element, and across passive element we always have the voltage drop, which we have shown in this table. Okay, so what happens here is that the for the passive elements, the current always enters positive and leaves negative. Therefore, when it enters the positive and leaves to negative elements, so it is the voltage drop, and it can be written here at this location. Okay, we are using equation number 1 here again, and according to this equation, VR is at the right end, which is for the voltage drop. Similarly, when currents enter, again we can see that by changing the direction of the current, now here for the source current is entering the positive elements and leaving to negative elements. So what is the concept here? This is a source active elements, so how come it drops voltage? According to our developed rules, we can see here that for the passive or active or passive elements, both can drop the voltage. Across both of the elements we can have the voltage drop. So voltage drop here, and this is again V of S, because it is the sum of all voltage drops. So we had 2 elements in our circuit, therefore at the left end we will have 0. Okay, so this is the equation for now this circuit, where we have changed the direction of the current, which is IR prime. It was IR here, now here IR prime. By allocating the variables here, we can have VS equal to minus VR, or by changing the values here, or by writing the values here, we will have minus IR prime multiplied by R, or the value of IR prime here is minus V of S by R. Putting the values here, we will get this is 10 volts, and this is basically 1 ohm. So now the value will be minus 10 amps instead of the positive 10 amps. So what is the concept here? How come it changes to negative, and what is meant by this negative sign, and what is meant by this positive sign? So actually, positive sign shows us that the direction which we have considered, which was clockwise, when it was positive 10 ampere, it was correct, while when we considered it is the counterclockwise, it is negative 10 amperes, and the negative sign shows us that the considered direction of the current is opposite that of the actual current direction. So this is the overall concept. Thank you so much, and I'll see hello again. So this is the tip number 10, in which we are going to discuss some circuit analysis methods. So far we have discussed two methods in our videos. The first one is the mesh current method, okay, or this one is also called the loop analysis method. Similarly, the other method we have used in our circuit analysis problem was the node voltage method, or this one is also called the nodal analysis. So in most of the problems in our book, we are given that you have to solve the specific circuit by using a certain type of the analysis method. But if a given a circuit is unknown, and we have to find the quantities by using the feasible method, which we have to choose ourselves, which method will you guys choose for yourself? Okay, so now as we have two methods here, so it always depends upon the circuit which you are going to solve. So suppose we have a circuit here. So a circuit here we have is this one. This is the circuit, okay, and here we have a resistor here. Let me draw it again. Okay, so this is basically a circuit in which we are given a current source here of, let's say, 5 amps. This is 1 ohm, 2 ohm, 5 ohm and 10 ohm, okay, and we are asked to find the voltage across the 2 ohm resistor. So we are not told that which method we are going to use here, or which method we have to use. So it is up to you, that you have to decide that whatever method is feasible for this circuit. So first of all, let us say we are going to use the node voltage method. So in using the node voltage method, here we have this node, and after finding out all the equations here, we will find the value of V1, and the value of V1 will be equal to V0, and we will have only one equation in node voltage method. We will have only one equation, and by solving that equation, we will get the value of V1, which will be the feasible solution. Similarly, if we have to use the mesh current method, what will we do? We will use two currents here. The first one here will be I1, the second one here will be I2. So the value of I1 is already given here, because this is the branch current in which the same current I1 is flowing, and the value of I1 is 5 amperes. Okay, so after going through all of these steps, we will have to find out the value of I2, and after finding the value of I2, what we have to do? We have to multiply the value of 2 with I2. Sorry, this is will not be the I2, but as the direction of the current is here, so here it will be I1 minus I2, that would be equal to the V0. Okay, so here we can see very easily that the node voltage method seems very feasible to be applied here in this circuit, but it is not always the case. So suppose we have another type of circuit here. We have another circuit here, like this one. Again, a branch current has been given, okay, and the current here is, let me call it I1, and the value of I1 is, let's say, 10 amps. The value here is 5 ohm, 10 ohm, 2 ohm, 5 ohm, and 20 ohm. I'm not writing the omegas with these quantities because it is already understood that these are the resistances here. So in order to avoid the confusion here, I have mentioned it. Okay, so let us first use the mesh current method. So in using the mesh current method, we can easily see here that we have to identify the meshes here. So this is the mesh number 1, this is 2, and this is 3. After identifying the meshes, we have to suppose the currents in these meshes. So these are the 3 currents, and we can easily again see here that very easily it can be seen here that the value of I1 is basically this, because the same branch current is flowing through this one, and that would be 10 amps. Okay, after finding it out, we will have to find out the equation for I2, then I3. So we will have some of equations of if we convert those equations into the matrices, so 2 by 2 matrices we will have, and solving the matrices of 2 by 2 dimensions will be easier for us. Okay, so that is the case when we have to use the mesh current method, because already a branch current has been given. Similarly, if we have to use, okay, so let me remove it. If we have to use the node voltage method, what will be the case then? So let me, this is 5, this is 2. Okay, these are the values here. So in finding the values here by using node voltage method, I'm presenting the node here by this red color. So how many nodes do I have here? I have 1, 2, 3, and this one, the 4 nodes here. Let me represent this one as a reference node here. So how many nodes will I have? This one will be V1, V2, V3. So then first of all, I have to use the node 1 and find the equation for node 1 here in terms of the voltage. Similarly, we have to find out the value or equation for V2, and similarly V3, and at the end, if we have to solve the equations by using the matrices, we will have a matrix of dimension 3 by 3. So it will be very difficult to solve the matrices of 3 by 3 instead of the matrices of dimension 2 by 2. Okay, so similarly, if that is the case with the equations, so the 3 equations with 3 unknowns will be very difficult to solve as compared 2 equations with 2 unknowns. Okay, so that is another case. Similarly, here, what is the takeaway here? Okay, so first of all, let us consider the takeaway here. So the takeaway here is that if you have some branch current given, so it will be always feasible for you to use the mesh current method. Okay, mesh current method or loop analysis is always feasible if the branch current is given. Okay, if the branch current is given. Similarly, another scenario occurs. Let me consider another circuit here. So to give you more examples here, this is another scenario in which we are given a circuit like this one. So that is the voltage source. Let me have it 5 volts. This is 20, this is 5, this is 7, this is 8. So again, we are not given the method with which we have to solve the circuit. So let me consider the mesh current method here again. So in solving the circuit by using the mesh current method, again we have to identify the number of loops here. So this is number 1, this is 2, this is 3. So this will be current I1, this will be I2, this will be I3. Again, there is no branch current given here. We will have a system of equation which will be composed of 3 equations with 3 unknowns, and similarly, if we convert those equations into the matrix form, we will have 3 by 3 matrix here, which will be a fat matrix. Okay, similarly, here we have to, what we have to do, we have to solve for I1, I2, I3, and that will be somehow difficult. Similarly, if we have to apply, let me apply the, okay, let me apply the node voltage here. So in using the node voltage here, I have to identify the node. So this is the node 1, this is 2, this is 3, and this whole is the node number 4. So let me again consider this one as the reference node. Similarly, these are the nodes where we have to find the voltages. Okay, V1, V2, V3, these are the nodes. So in solving this circuit, we can very easily see that the voltage of at these two nodes are already given. So the value of voltage here is V1 and the value of V1 is 5 volts. Similarly, the value of V3 is short circuited with this reference node, so the value of V3 is 0 volts. Okay, so here we just have to find the value of V2 by using the equation which we will form in terms of all the currents. Okay, so here we will have to find out the value of V2, and here we will have just one equation and one unknown, and solving the same problem with 3 by 3 dimension matrix is now very easier by using the one equation and one unknown. So it always depend upon the method which you are going to prefer. So if you are given any branch voltage here in any circuit, if branch voltages are given, if branch voltages are known, it is always feasible to use nodal analysis. Okay, so that is the takeaway from this circuit. Similarly, another scenario here is that it always depend upon the selection of your reference node. Okay, in any circuit you have to see that whether the selected reference node is making my problem easier for me or is it making it harder. So in many other situations, in many other circuits, it will be your duty to select the reference node. It is not always the case, because we can see in our problems that in most of the problems we have selected a reference node in which with which most of the branches were connected. But you shouldn't follow the same convention if the same convention is making the problem harder for you. You can use any other node here if the same node is making the problem easier for you. Okay, so that's it for today. This is the tip number 10, and I hope it will make your life easier while solving many type of circuits. So that's it, and I will see you with the next tip. Thank you so much and take care of yourself. Hi again. So in this video we are going to discuss the tip number 11, in which we are going to discuss a very easier method for solving a circuit by using the mesh current methods. Okay, so suppose you have a circuit here. Let me have a same circuit here. These are the resistors which are in the circuit. So that is the voltage source. Let me have it 50 volts. This is 2, this is let me have it 4 ohm, this is, let me have it 6 ohm, again this is 2 ohm, and this is, let me have it 10 ohm. Okay, so by solving any circuit by using the mesh current method, what are the steps? So in first step you have to identify the number of closed paths, loops or meshes in a circuit. So here we have 3 meshes. This is mesh number 1, this is 2, this is 3. Okay, after identifying the meshes, what you have to do, you have to suppose the currents. Let me call it I1 in the mesh number 1. In mesh number 2 I have I2 current, and in mesh number 3 I have I3 current, which is denoted by this green color. Okay, after it, what we have to do, we have to write the equations. I have to select each of the mesh here, and after selecting the mesh I have to apply KVL in each mesh. Okay, after applying the KVL in each mesh here and then simplifying the equations, it will be somehow harder for us to find all the equations, and at the end we have to solve the equations as well by using whatever method you are going to use. By using the matrices or any other method. So it will be harder, take so much time for constructing the equations and then solving those equations. Instead of that, I can use another method here, which I am going to describe here. So what is that method? So in order to apply or construct the equation for mesh number 1, let me have mesh number 1. So I'm not applying the KVL here. Actually at the back end I am basically applying the KVL, but in order to simplify the method, first of all you have to, in which mesh you are, you have to sum all the resistances, the values of all the resistances there, and multiply that with the current here. Okay, so what are the resistors here in mesh number 1? Those are 2 and 4. So 2 plus 4 is 6, and what is the current in that mesh? I have I1. Okay, so you have to use 6 I1 here. Similarly, you have here mesh number 2, and which resistor is shared between the mesh number 1 and mesh number 2? That is the 4, and you just have to write the negative sign with that resistor which is shared between the two meshes, and then write the current which is in the mesh which is shared with the resistor here, okay, with which the resistor is shared. Similarly, in mesh number 3, it is again sharing another resistor here, and that is the 2. Again I have to write a negative sign with the shared resistor here, and after writing the negative sign here, I have to write the value of the current which is in the mesh, and that would be I3. And here, as I have the voltage source here as well, so plus 50 volts, because it is entering through minus and leaving through positive, so that is the voltage rise, and it will be at the other end. Okay, similarly, in using the mesh current method in mesh number 2 here, let me use the same procedure. So here, what is the mesh here? This is mesh number 2, and adding all the resistors in mesh number 2 here, I have to add 6 and 4 and 2. So what will happen here? I will have 6 plus 2, 6 plus 4 plus 2, that is the 12. And which mesh is it? This is the second mesh, so I have to write the current I2. Okay, so that is the 12I2. Similarly, which resistor it is sharing with the other meshes? So the resistor 4, it is sharing with the mesh number 1, so therefore I have to write the negative sign with 4. And in which mesh it is? It is in first mesh, so that would be minus 4I1, and only the positive sign which will be with the current in which mesh you are in. Okay, so that is minus 4I1 plus 12I2, and another resistor which is it sharing is this 2 ohm, which is shared between the second mesh and the third mesh. So similar conditions will be applied here, and minus 2I3 will be here, as there is no voltage source here, so I will write 0 here. Similarly, in mesh number 3, what will happen? You can again see here that in mesh number 3 I have 3 resistors which are 2, 2 and 10. So adding them together, I will have 14I3, and it will always be positive. Okay, so similarly, this is sharing this 2 with the mesh number 1, so I will write minus 2I1. Okay, similarly, this 2 is shared between the mesh number 3 and mesh number 2, so that would be minus 2I2. Okay, and as there is no voltage source here, so I will write here 0. Okay, so this is the system of equations in which I have three equations. Let me call it equation number 1, this is 2, and this is 3. So whatever method you like, you can solve these three equations with three unknowns, which are I1, I2, and I3. So that is the method which will make your life easier, and this is tip number 11. I hope you will find it useful. Thank you so much. Hi all. This problem we have to find the value of V1 by using the node voltage method. Okay, so this question also involves source which is called a current dependent voltage source. Okay, the value of this voltage source depends upon the current I5 which is flowing through this 3 ohm resistor. So this is basically a very interesting problem in which we can see the selection of a reference node can basically affect the complexity of our problem. So let us first draw the simplified version of this circuit. Okay, so now here we have some nodes. Basically we have 4 nodes here. These are basically 1, 2, 3, and 4, these 4 nodes, and the as we can see that any of the node can be selected as a reference node. But which node to select as a reference node? If we select this one, so the voltage will be known here, but the other values we have to calculate. But if we select this one as our reference node, so how would it simplify our problem? It will simplify because now here the two sources will be connected in direct connection with this reference node. Okay, so what are those voltage sources? The first one is this one and the second one is this one. So it means the voltage here and the voltage here will be known. The voltage here will be minus 60 volts, and the voltage here will be 6I5. Okay, so the voltages at these 2 points will be known, and we have to solve for this voltage only then. Okay, so let us consider this one as a reference node, and considering this one as V1, this one as V2, and this one as V3, we can write the equation here. First of all, let us write the known voltages. So the first known voltage is basically the V1. So the value of V1 is basically minus 60 volts. Okay, so this is the known voltage, and similarly the value of V3 is also known, and that is 6I5. Okay, similarly we can see here that the value of I5 is basically the current which is flowing from V3 to V2 by the resistor 3. So that's why I can write from node here that the value of I5 is V3 potential difference, V3 minus V2 divided by 3. Okay, so putting the values here, putting equation B in A. Okay, when we put equation B in A, I will get V3 equal to 6 V3 minus V2 divided by 3, which will ultimately give me 3 into 2, and it will ultimately give me V3 equal to 2V3 minus 2V2, or it will be equal to moving this V3 here, I will get, sorry, this is V2, I will get the minus 2V2 plus V3 equal to 0. Okay, I have simplified it and also rearranged it, and I will get this equation. So let me call this equation as equation C. Okay, so now move towards the node V2. So here we have some currents. First current is here, second one is here, and third one is here. Let me call it I1, I2, and I3. So according to at node 2, applying KCL, I will get I1 plus I2 plus I3 is equal to 0. And so I will get here 21 V2 minus 8 V3, and moving this 60 at the other side, I will get minus 60. So let me call this equation as the equation D. Okay, now as I have both the equations, and let me solve them. The value of V2 would be equal to minus 12 volt. Okay, so that is the value of the V2. As now we have to find the value of V1, which is here. Okay, so in order to find the value of V1, small v1, we should have the values of the two potentials which are at the ends of this 24 ohm resistor. So we know the value of V1. Now we have also calculated the value of V2, and we know that the value of small v1 is equal to V2 minus V1. Okay, in order to find the value of this V1, do we know the value of V2? Yes, we just calculated it, and the value of it is minus 12. Similarly, the value of V1 was also calculated, and it was minus 60. So writing minus 60 here, I will get this one. So V1 is equal to minus 12 plus 60, which will ultimately give me the 48 volts, which is the answer of this question. Okay, so in this question we have seen how to select the feasible node as a reference node, so that our questions can be simplified in solving for the desired values. So I think it will clarify your concepts regarding the node voltage methods and the applicability of the dependent voltage sources in it. We will solve more questions in our next video. Till then, thank you. Welcome back, students. So last time we solved some questions in which we were asked to find the value of the voltages or currents by using the specific method which was given in the question statement. From this question onwards, we have to find the specified value, or the values which we are asked to find out by using the convenient method which we find feasible for us. Okay, so this is our circuit, and we are told to find out the power delivered by the 2 amps source. Okay, so as we know that the value of the power dissipation by any source can be find out by using this equation, P is equal to IV. As in the case of a current source, we are given the value of current, but we don't know the value of voltage, so we have to find out the voltage here. Okay, so now we have to choose between the two methods which we recently studied, which are basically the node voltage method and the mesh current method. So if we consider this circuit or solve this circuit by using the mesh current method, so we can see here that we will have two meshes here. The first one will be here, second one will be here. We have to consider the currents 1 and 2 here in any direction. Let me consider them in the clockwise direction, like this one. So when we will solve them, we can again see here that we have a current source in the branch which is shared by the two meshes, and two equations we will have, and after solving the two equations we will get the current, and after the current we will have to find out the value of the voltage here, the value of voltage here, and from these equations we have to find out the voltage here, and we will also use a Kirchhoff's voltage law. Okay, so that method will be somehow very lengthy. So suppose if we are not using the mesh current method, so if we use here the node voltage method, so the node voltage method, what is the first step? We have to identify the number of nodes. So the first node is here and the second node is here. So if we consider this one as R, reference node. So this and this one as our node where we have to find the voltage. So this is the only voltage which we have to find, because this one is the required voltage. So the question here by using the node voltage method will be quite simple. Okay, so we can also draw a simplified version of this circuit, and that would be like this one. Okay, this one is our reference node, this is our voltage here, this is the 15, this is 10, this is plus minus 25, this is plus minus 20, and now we have three currents. Let me denote those currents by red color. Okay, so this is, let me call it I1, I2, and this is the I3. Okay, so now here applying KCL here, we can see that the value of I1 plus I2 plus I3, this is equal to 0, or V naught is equal to the 175 divided by 5, which will ultimately give me the value of 35 volts. So this is the voltage, this is the value of voltage which I have to find out, or which is required by me. Okay, so now as I have find out the value of this voltage here, so I can easily find out the power dissipated by this source, and that is basically the 2 ampere, and the value of current here is the 2 multiplied by the voltage across is 35, so this is now 70. Okay, so this is the 70 volt. So what was the concept behind solving this question? So you have to see which method is feasible for you to solve any circuit, which will give you ease in finding or in calculating the quantities which are required in any circuit. Okay, so that's it for this question, and I will see you in the next video. Till then, thank you so much and take care of yourself. Hello students, I hope all of you will be fine. So this is our lecture on delta star circuits, that how to solve or find the required quantities in a circuit which are neither in series nor in parallel configuration. So this is one of the circuits like those configurations, because here you can see that here 100 ohm, 125 ohm, these are neither in series nor in parallel, because the two ends are neither connected to each other nor in series with each other. So what we have to do, we have to find the current and power supplied by the 40 volt source in the circuit shown here in this figure. So what we have to do, first of all, we have to find the equivalent resistance, and after finding the equivalent resistance, we have to go towards the current and power supplied by the circuit. So in first step, what we have to do, this is our circuit here. So in this circuit, this one is, these are our resistors which are given. Okay, this one, this one. Okay, these are our resistors. So this is 5 ohm, this is 100 ohm, this is 125 ohm, this is 25, this is 37.5, and similarly 40, and these are connected with a 40 volt source. So in order to find the equivalent resistance, we have to convert any of these two deltas. These two are basically the delta circuits, and converting any of these delta circuits into star configuration will basically make this circuit easier to solve. So the equivalent circuit will become like, you can see that here we will have this circuit, which is basically this series circuit, and A and 5 are in series, while this circuit, which is basically the series combination of resistor B and 40, these are again in series, while C and 37.5 are again in series, and the configuration of these two are basically in parallel. So converting them into some unambiguous form, it will become like this one. Okay, so here this is 5 ohm resistor, the resistor A is 50 ohm. Similarly, the value of resistor B is 10 ohm, and the resistor here is 40. The resistor here now we have find out is 12.5, which is the value of resistor C, and similarly this is 37.5. So the equivalent resistance is, okay, this one, this is here, and here this one, this one, these two are now in parallel, and the adding them together, because now these two are in series, these two are in series, and these two are again in series. And in series we know that to find the equivalent resistance, the individual resistances are added. So here it will become 50 ohm, it again becomes 50 ohm, this is now 50, and this is 5 ohm. Okay, so let me go down, let me go down here and solving it here. 40 volts. Okay, so this is now our equivalent circuit, where 80 ohm is our equivalent resistance. So now here we can easily find out the value of current which is flowing or provided by the 40 volt source. So that is basically, we can find it out by using the Ohm's law. So I is equal to V by R. V is 40 divided by 80, so it is now 0.5 amperes. Okay, so this is the current which is provided by the source. Similarly, the power provided by the 40 volt source is equal to I40 multiplied by 40, which is P is equal to IV. So by using the values here, 0.5 multiplied by 40, so this is now 20 watts. Okay, so this is the overall circuit, and the actual consideration behind solving the circuit like this one is to see that what are the configurations which are neither series nor in parallel combinations, and how to solve the circuits like those ones. So initially we have to find the equivalent resistance, pick any of the two deltas, or pick any one of the two deltas, or any of the stars, and convert them into the other configuration, and you will see that is basically our circuit. And here we have used the conventional circuit laws to find out the equivalent resistance, and after finding the equivalent resistance we find out the current and power supplied by the 40 volt source. So that's it for today, and we will solve more questions like this one in our upcoming videos. So thank you so much, and I'll see you soon.